Page 482, number 23. Again, we have the same directions as we did for number 11 and for 15. We're to use an algebraic model to eliminate the parameter and identify the graph. Now, 23 is a lot different than 11 and 15 because we're dealing with trig functions. And there's a little bit of a trick, but considering how much work we've done with identities, trig identities over the past month, hopefully the trick will be kind of obvious here in a second. It doesn't make sense to do an inverse cosine because then you're just going to have some very difficult terms to deal with. What does make sense is to realize how you can simplify sine and cosine by using a Pythagorean identity. So if I write these two equations in this way, taking x squared plus y squared, and I can substitute their values in, what I'm doing is squaring my x, which is going to be 5 cosine t, and I'm squaring my y, which is 5 sine t, and I can already see what type of equation. Hopefully you recognize the equation here on the left as a certain shape, but I'm going to go ahead and go through this. So I'm going to have 25 cosine squared t plus 25 sine squared t, and I'm going to factor out the 25, and there is the Pythagorean identity, cosine squared t plus sine squared t, which you all know to be 1. So what I've created is the equation of a circle, x squared plus y squared equals 25, that has a radius of 5 and is centered at the origin at 0, 0. And now I can verify that on my graphing calculator, first on the Inspire. So there are the two equations, and you can see it's a circle and it's centered, and if you count along any of the axes, you can see that it touches at 5 or negative 5. Now, if you go to graph it in your 84, what you might see is that it doesn't look round. What you want to do, and I'll show you if I just choose zoom standard, it's not going to look very circular. It's going to more look like an ellipse. So you want to choose zoom square so that it evens out the axes and you get yourself a real circle on the screen. So the two parametric equations give us the equation of a circle.